Alright, so now we're going to move on to example 2 here, or problem number 2. Okay, we have this resistor drawn, or this circuit drawn. We have our resistance values, we have the battery. They want us to find equivalent resistance, which is just RT, total resistance current going through everything, and the voltage drop. So, same thing, we're going to make ourselves a little Ohm's law table here, starting with our V. I'll say right about, let's say right here. Okay, so we have V, we have I, and we have R. So we're gonna just do this for each of them. It's just very easy to kind of keep everything in order. Okay, there's 3 resistors, so we're gonna make 3 columns or 3 rows, and then 1 for the total. Okay. Now, what are the only pieces of information we're given? Well, we're given resistor 1, so that's going to go with R1. I'm going to write that in. 4 ohms. We're given R2 of 8 ohms. And we're given R3 of 12 ohms. Now, RT is to add all of them up. So 4 plus 8 plus 12, and we're going to get 24 ohms. And then the other piece of information that we're given is the total voltage, the battery, which is 24 volts. Okay, so again, we can't solve for the voltage drops, V1, V2, V3, because we don't have the current for any of them. So in order to use Ohm's law, our triangle, all right, you need to have 2 of the three variables. So we do right here, we have VT and we have RT. So using the triangle, if we cover up I, what does that equal? That is going to equal IT is equal to VT over RT. So very simple. Then you just plug in your values. VT was 24. RT was also 24 ohms. So divide out, and that is going to give us 1 amp. Okay, now that we have that, we can plug it in here. Alright, series circuit. Current is the same everywhere along this circuit, so we can just write those in. And now we have 2 out of our 3 variables. So, remember, V1 goes with I1 and R1. So, very simple, just 1 amp times our 4 ohms. Going to get 4 volts. Okay, V2 is I2 and R2, and we have 1 times 8, 8 volts, and the last here is V3, which is I3 and R3, 1 times 12, and that gives us 12 volts. So again, remember, the sum of the voltage drops, V1 plus however many there are, V1 through whatever. In this case it's 3, so V1 plus V2 plus V3 has to equal VT. If not, we have to round and kind of changing them up accordingly. This one works out nice and perfect. This is just 24 volts, which matches this guy, so we're good. And now we can write these values in. 4 volts, 8 volts, 12 volts.